Hi everyone, I hope you're okay guys, and I really hope that the videos we keep uploading are helping you out towards your final examination. Please guys, if you're new to the channel, don't forget to subscribe. If the channel is helping you, please tell your peers to come and join us as well. Help us grow the channel guys, to reach other people that they might need the help. Okay, today guys we are just focusing on acids and bases, and it's just the theory part of it. The most important part will be covered in this video. And then there are two theories guys that we focus on whenever we talk about acids and bases. The first one is the Arrhenius theory. Arrhenius theory, and then the Brønsred-Lowry. And the Brønsred-Lowry theory are together. So according to the Arrhenius theory guys, please note that Arrhenius simply states that an acid is a substance that ionizes in water to form a higher concentration of hydronium ions. Hydronium ions can be H plus or H3O plus. An acid is a substance that ionizes in water to form a higher concentration of hydronium ions. And then a base is a substance that dissociates in water to form a higher concentration of hydroxide ions. A base is a substance that ionizes in water to form a higher concentration of hydroxide ions. From the Arrhenius theory guys, we can come up with a deduction that whenever you combine an acid and a base, you will always form salt plus water, always the time. Together we'll talk about this these types of reactions whenever we do calculations and titration and stuff. Okay, just for now, please note that whenever you add an acid and a base, or you mix an acid and a base, you will form salt and water. Okay, then now let's go to Lowry and Brønsted. Lowry and Brønsted simply says that an acid is a substance that ionizes in a solution. An acid is a substance that ionizes in a solution to donate a proton. The H plus ion can be regarded as a proton. Are you together? So you can say an acid is a substance that ionizes in water to donate a proton or to donate a hydronium ion. Are you together? You can either say one of the two, it's okay. And then a base is a substance that dissociates in water or in a solution to accept a proton. Are you together? So one accepts a proton and the other donates a proton. So these types of reactions, they are called protolysis. Are you together? Please note that guys, from the definition Lowry-Brønsted, we can deduce, we can have the conjugate base pairs. Are you together? Acid base pairs. What are those? Whenever I take my acid, let me take HCl plus water. This will give me H3O plus the Cl minus. Remember that guys, an acid is a substance that ionizes in water to form a hydronium to donate a proton rather, in this case. Okay, so if you focus on the fourth reaction here, HCl has become Cl minus. All right, together. So HCl has donated a proton, so this one will become my acid. Are you together? and then H2O has gained a proton to become H3O plus. You can all see that, right? So that means H2O is a base in this reaction. And now whenever I focus on the reverse reaction, H3O plus, for it to become H2O plus, it has to donate one proton. This simply means that H3O plus is an acid. And then Cl minus, for it to become HCl, it has to donate, it has to gain a proton or accept a proton. So that means Cl minus is a base. So whenever they say to you, write down the acid-base conjugate pairs, they simply say to you, write down one acid on the left-hand side and pair it with the base on the other side. So in this case, my acid is HCl. Its conjugate base pair will be Cl minus. All right, together. Another one, I have an acid which is H3O plus. Its conjugate base pair is H2O. All right, together. So whenever you look at the acid-base conjugate pairs, there are two things which almost look the same. The only difference they have is the age. Are you together? Why? Because according to Lowry-Brønsted theory, we focus more on protolysis. One has to donate and one has to gain a proton. So we can see that this almost looks like this one. The only difference is that this one has an H. Are you together? We can even take nitric acid and do the same thing. HNO3 plus H2O. This will give us H3O plus the nitrate ion, NO3 minus. Okay, let me cook. HNO3 will become NO3 minus, which simply means that HNO3 has donated a proton. So this is an acid. Are you together? H2O will become H3O plus, which simply means that H2O has accepted a proton, which means H2O is a base. Now whenever I focus on the reverse reaction, H3O plus will become H2O. How so? By donating a proton, which simply means H3O plus is a base. Are you together? Same thing happens. NO3 minus will become HNO3. By what? By accepting a proton, which simply means NO3 minus is a base. So the acid-base conjugate pairs, I have nitric acid and the nitrate ion. Are you together? And then I also have the H3O plus and H2O. The only difference between these two is an H. The only difference is an H. Are you together? And please note, guys, that I was only dealing with monoprotic acids. A monoprotic acid is an acid that ionizes in water to donate one proton. Are you together? We have three types of acids in your syllabus. No? We have a monoprotic acid, a diprotic acid, and a triprotic acid. A diprotic acid is the one that donates 2 protons. A triprotic acid is the one that donates 3 protons. Are you together? So in this case, let's now focus on sulfuric acid. Sulfuric acid is a diprotic acid, right? Which simply means it donates a proton. It donates 2 protons rather. And it does that in a 2-step process, but I will only write the final reaction. Okay, we can all see that H2SO4, which is the is the acid because it has donated 2 protons for it to become SO4 2-. So this one is my diprotic acid. Are you together? And then remember that I'm still focusing on the fourth reaction. Yeah? H2O has now become H3O plus, which means H2O has accepted a proton. So H2O is my base. And then whenever I focus on my reverse reaction, the H3O plus will become H2O by giving away a proton. So this thing will become an acid because it donates a proton. Are you together? And then SO4 2- will become H2SO4 by accepting 2 protons. So this one will become my base. So whenever I write the acid base conjugate pairs, I have H2SO4 pairing with the SO4 2-. And then I also have the H3O plus pairing with H2O. Are you together? So this is how, guys, you deal with this is how you deal with protolysis with regards to an acid. Are you together? I'll do the same thing with the base. Let's take ammonia, NH3 plus H2O. Okay, NH3 plus H2O, right? Remember that ammonia is a base, so ammonia will have to accept a proton. Are you together? So we'll have NH4 plus OH minus. Are you together? So whenever you focus on the forward reaction, NH3 has accepted a proton for it to become NH4. So this is my base. Are you together? H2O has donated a proton for it to become OH minus. So this is an acid. And then whenever you focus on the reverse reaction, NH4 will donate a proton for it to become NH3. So NH4 is an acid. OH minus will have to accept a proton for it to become H2O. So OH minus is a base. So in this case, for my acid base conjugate pairs, I know that I have NH4 plus as my acid and the conjugate pair is NH3. Are you together? And then I have water, H2O as my acid and the OH minus as my base. Please check that whenever I react a base with water, the water now becomes an acid, right? But previously I reacted an acid and water, and the water was a base. So water has the ability to act as a base as well as acting as an acid. Are you together? So we say that water is an ampholyte or water is amphiprotic because it has the ability to gain or accept an electron. Are you together? Okay, so these are the basic principles, guys, of acids and bases, right? How do you know that a substance we have is a base or an acid? Okay, there is a scale that we use to measure a substance's acidity or alkalinity. It's called a pH scale. Are you together? It's a pH scale. If ever your substance has a pH which is lower, which is between 0 and 7, just know that your substance is an acid. Are you together? If your substance has a pH which is above 7 but lower than 14, that means your substance is a base. Are you together? And then obviously we have strong acids and strong bases, right? If your substance has a pH which is between let's say 11 and 14, that means you have a strong base. You have a strong base, right? So if the pH is just between 7 and 10, you simply have a weak base. Are you together? Same thing applies. If the acid is between 0 and 3, you have a strong acid. If the pH of the acid is between 3 and 7, or 4 and 7 rather, you have a weak base. Are you together? So this is how you measure that your base or an acid is a strong base, is a strong acid or a strong base. Are you together? We'll talk about calculation of pH on another video. For now, I just want us to understand the pH scale. Please, guys, remember that whenever we gave a definition, we said according to Arrhenius, an acid is a substance that produces a higher concentration of hydronium ions. Remember that, no? So it doesn't mean that if something is an acid, it doesn't have hydroxide ions. It does have hydroxide ions, but their quantity is too small, such that it may be negligible. Are you together? So just know that for the pH scale, at the bottom we do have our pOH scale. Are you together? So our pOH scale goes in this form, which simply means that if ever the pH of a substance is equal to 1, that means its pOH is equal to 13 rather. Its pOH is equal to 13. Are you together? So remember that you can either form a higher concentration of hydronium ions or a higher concentration of hydroxide ions. Please remember this. Where do I get this from? I know that whenever I add a pH plus pOH, I will get 14, because the scale starts from 0 to 14. Are you together? So if the pH of my solution is 1, simply means the pOH has to be 13. If the pH of my solution is 12, that means the pOH of the solution has to be 2. Are you together? Because as long as you do have an acid will produce a higher concentration of hydronium ions. It doesn't mean that it doesn't have hydroxide ions. It doesn't mean that the solution does not have hydroxide ions. As long as your pH is not equal to 0, that means there is a small number of hydroxide ions in your solution. As long as your pH is not equal to 14, simply means there is a small amount of hydronium ions in your solution. Are you together? So for now, guys, just know that we use pH for us to measure the basicity and the alkalinity of a substance. Are you together? For the next video, guys, I will just focus on calculations on how to calculate pH of an acid, and both acid and bases, and then maybe on the other video I'll touch on titration and maybe finding the pH whenever I mix an acid and a base, and then I'll do hydrolysis as well. So please, guys, stay tuned and wait for the videos. If you like the content we are sharing, ungasabi, thatha le nto ayinabungozi.